Alright, welcome back to another video by Firestarter Graphics and Engineering. Today we're going to be talking about numerical methods and using Excel to solve some numerical method problems. So, here's a quiz question from a numerical methods class. It says that this data set of n is equal to 15, so we have 15 inputs and 15 outputs, contains measurements of yield from an experiment done at 5 different temperature levels. The variables are y is equal to the yield and x is equal to the temperature in degrees Fahrenheit. The table below gives the data. Determine the coefficients of the polynomial y equals a2x squared plus a1x plus a naught. Alright, so back in our college algebra days, we learned how to find coefficients of polynomials by the remainder theorem. It's where you take factors, and we called those p, and then we divide them by another thing, we called that q, and it was called your p's and q's, and then you did the polynomial long division, and if you got a remainder, you keep going until you have no remainder, and that was possibly a coefficient. For this problem, that would take way too long. So we're going to use a matrix, a very large matrix, which still would take way too long. However, Excel is really good at matrix math. Now, you can use MATLAB for this. It's no big deal which program you use, but today we're going to be using Excel. So here's kind of the pattern that we need for solving the coefficients of a polynomial when given a data set such as this. Top left corner is going to be your n. We call this just n. Yeah, that's it. It's nothing fancy. Anyway, it's going to be whatever size your data set is, which in our case is 15. And then we have all these summations. Now, the key is you have however many coefficients you need to find is how large your matrix is going to be in row column. For example, we need 3 coefficients, so we're going to be using a 3 by 3. If you have third degree polynomial, I think that's 4 coefficients, so you'll need a 4 by 4. This is a 4th degree polynomial, so you'll need a 5 by 5. In this example of this picture is a 4th degree polynomial. The picture above is the one that we're going to be using. So here on the left hand side, let's go ahead and delete this. We do not need this anymore. Actually, nope, we don't. So let's go ahead and get going. So here we have our x or y's, and then we have xi squared, xi cubed, and xi to the 4th. That's just our x values. Because we're going to need the summation of our xi right here, summation of our xi squareds here, and cubes and fourths and all this fun business, and then we need an xyi column. Okay, so we need to, like I said, we need to add a column here for our xi, yi, and as well as our xi, yi squared. Is that what it was? Nope, that is backwards. It's going to be your xi squared times yi. So let's kind of run down how we're going to do this. I'll show you one column here, and then you can probably figure out how to fill out the rest. So for this one, it's literally just going to be equals. We're just going to click that value, and we're going to square it, and that is it. And then we're going to do the same thing here, but cubed. This will be, you can type in the column number if you want. I'm just so used to clicking. And then what you're going to do is you're going to drag those down, and this will just copy that formula down. So we're going to have something very similar to this. Actually, not very similar. This is what you're going to have when you do it. Okay, so now we need to do the multiplication of this. So I'm going to let you guys go ahead and do that. Okay, so I've gone ahead and filled all this in by just using some basic formulas. As you can see here as I click through. Don't forget the equal sign. These ones, no formulas. So now we're just going to do the sums of everything. This isn't too bad. So we're going to start with the x column. So I'm going to just say is this is equal to the sum of, I'm just going to highlight all of these. And that's all you're going to do all the way through. So we'll go ahead and do this one. Oops, until it's all the way done. Now you don't have to click and drag, but it's just easier, I think. Okay, so I've gone ahead and we have calculated our sums. Now, an FYI, remember the sum of yi, xi, yi, xi squared yi are actually our b values. So that one, this one, and this one. That is our b values. Because remember, we need some sort of, when we deal with a matrix, it's going to be ax equals b. And then we're going to take the inverse of A, which means if we multiply the inverse by the B matrix, we will get our unknowns. So that's our goal. And that's actually really simple in Excel. So just because I want to, let's start with our A matrix, which we can see is all the things right here. So I'm just going to hit A. I'm just going to type that in. So the first one is going to be 15 because that is how many nodes we're dealing with, or data points I should say. And then this is just the sum of xi. You could type it in, or you could hit equals and that, and you can go all the way through and fill it in. The reason why, I don't know, sometimes I like to hand type them in, but if you mess up by one digit, it throws everything off. So it's better just to do this. So now find the sum of this one right here. And then you're just going to go through until this is all the way complete. Okay, so I went ahead and filled this in, and also the b values. I also put, here's our x values, here's our unknowns, and here's the a inverse. So let's go ahead and create the a inverse. So the first thing that you want to do is you need to highlight a 3 by 3 because that's the kind of matrix we're dealing with. And then you're just going to hit equals, and you're going to type in m in, and you'll, let's see, and you'll see it says inverse. When you type in MINV for matrix inverse, you're going to hit tab for completion. Now you're going to highlight the array that you want to deal with, which is this one. Now, depending on which version of Excel you're using, you either need to hit Control-Shift-Enter to spill and copy this formula into the entire 3 by 3, or if you're using a newer version like I am, if you hit Enter, it's going to auto-spill. So as you can look at this, this is our inverse now. So now all we have to do is, for our unknowns, highlight this section, and we know that this is equal to the matrix multiplication, so there it is, of our A inverse, and it's important that you select the 3 by 3 first, by our B matrix. Close parentheses, Control-Shift-Enter, or just Enter, and there's your coefficients. So now we know that we have y is equal to, let's see, 0.001x squared minus 0.153x plus 7.96. So how do we verify which unknown is which? Well, that's a great question. So if we take our actual data, okay, we go to insert, and we're going to do a scatter chart with a smooth. That is definitely not what we want. Scatter plot, that's one we want. And we right click on the graph and we add a trend line. We want to go to polynomial, order of 2, display equation, and then you can close, and you can see the equation up here. That will tell us how close we are, and we were spot on. So we have the same values. Oh, actually we got a little bit more accurate with the matrix than what they did. They just rounded up, but that's okay. So anyway, pretty simple and really, really powerful tool to figure out trend lines and to fit curves to all our data, and also to find the missing coefficients. Hopefully in the real world we won't have missing coefficients, but if we ever do, we just modeled the equation that we need for our data. So anyways, thank you for watching, and I hope that helps.